Welcome you all for the second video with Automation and Control System Laboratory. We are going to see the second part of introduction of fluid power system. In the last video, we discussed about the need, types, different types of fluid power, why we need fluid power, what are the benefits, what are the applications, then what are the basic components of hydraulic system, how it will be used in industries, what is the comparison between pneumatics and hydraulics. So all we discussed in the last slide. In this video, we are going to discuss about the basic components of pneumatic system and how we are going to represent it in a graphical form, and what are the actuating devices we used to have in our pneumatic and hydraulic system. Okay. So now we'll go for the basic components of pneumatic system. As mentioned earlier in the last video, we are having a number of basic components in the pneumatic system. Some of them are listed here. So air compressor, FRL unit, that means fluid. These are a filter, regulator and lubricator. Then valves we are having. Then timers, counters, flow control valves, directional valves, then cylinders, motors we are having. So we can see here. So we can see the compressor. Then this all part is compressor. From here we are having a outlet. That outlet we are having a FRL unit. From there we are sending to the valve. Then it is going to the actuator. So these are all the basic components we have in our pneumatic. One by one we can see. So in the pneumatic system we are having air filters. It will be kept in the inlet of compressor. We have to filter the contaminants of air in micro level or nano level particles. Then we have to filter the moisture contents. So we need some dryer also. The second one, we have a compressor. We have different types of compressors we are having. We'll see in later on. It is used to generate air, that is pressurized air by using compressor. It's either diesel or electrical operated. So based on the requirement of the particular industry, we can go for the suitable capacity of compressor. Then air coolers we are having. So in compressor itself we are having, if 2-stage, 3-stage compressors we are having, so we need some air coolers. During compression operation, air temperature increases. Therefore, coolers are used to reduce the temperature of the compressor. Okay. Then as stated earlier, dryer also we are having. The water vapor or moisture in the air is separated from the air by using a dryer. Then we have some valves. So valves used to control the direction, control the flow, control the pressure. So it is used to regulate, control and monitor the control of direction, pressure, etc. Direction, flow, pressure, etc. Depends upon your need. We have different types. So some of the valves we use as a switch. Okay. Then actuators we are having a rotary actuator and linear actuators we are having. Air cylinders and motors are used to obtain the required movements of the mechanical elements of pneumatic system. Then this compressor has to actuate via electric external power source. To transform electric energy into mechanical energy, it is used to drive the compressor. Then in compressor itself, we are having a secondary part. There we have to store, it's a receiver, we have to store the pressurized air. Whenever the pressure drops, immediately automatically the compressor switched on to maintain the pressure inside the compressor or the storage tank. So these are all the different components of. So we can see here the structure of the pneumatic control system, how the flow will be there. So we have an energy supplier, that is a compressor we are having. It's a symbolic representation of the compressor. Then we are having some input elements. That means we are having the input elements we used as a switch. You can have a switch or push button. We are here. What type of switch we are using? Push button switch. It's spring return switch we are using. Then we are having a shuttle valve. Then we have a direction control valve. Then we are having an actuating device. So this is the structure of a pneumatic control system. It starts from energy. Then we have to give the input element, the signal input signal we are giving. Then processing signal, then control signal, then output. So it's a pneumatic system structure of the signal flow. So first one we have see the common as a compressor. So you can see it's a symbolic representation of the compressor. We circle with arrow mark. It's a symbolic representation of a compressor. Okay, it's a symbolic representation of the compressor. So you can see here the we can see the symbol of the compressor. So this is a pictorial way of a compressor. It's a tank to receive and store the air. Then we have some filter. So different types of compressor we are having. Initially, we can classify into piston compressor, screw compressor, lobe compressor, and in compressor. These are the different types of compressor. So we can see some of the compressor listed here. Maybe it's a piston compressor or rotary compressor. We can have, for example, piston compressor. We can have single stage piston compressor, then double stage, double acting piston compressor, single acting piston compressor, double acting piston compressor, and multi-stage also we are having a multi-stage. So different types we are having. Single stage means it's like an IC engine. We are having input and output. Then air inlet we are having. Then air output. Then it has a BDC center and TDC center. So bottom dead center TDC. When the electrical motor switch on, immediately it rotates, the crankshaft rotates, it moves the connecting rod. So the piston moves up and down. When it is coming down, air from inside or section across. When it is moving towards outside upwards, what will happen means air outlet will be there. So air outlet will be there. It's a pressurized air. So it will be stored in a tank. If we need more pressure, so single stage we can have up to 6 bar only. But when we are going for double acting, or two stage, three stage means more than 15 bar also we can have. So as I already stated in the first video, you can see we can have the working pressure of 6 to 8 bar. So if you want to go for higher pressure, less than 12 bar, we can go for multi-stage compressor. So here we can see a double acting cylinder. So both inlet, both the stroke we are getting inlet as well as the outlet. Okay. So more storage will be there. The next one is a screw compressor we are having. If more capacity we need, high capacity, high power, then high pressure we need means we can go for screw compressor. Similarly, in rotary type we are having vane compressor and lobe compressor we are having. More volume we are getting, more pressure also we are getting. So these are all the different types of compressor. So now we see the valves. So first one is direction controller DCV. So here some of the valves are listed. The symbolic symbols are listed. The valves in symbol. For example, DCV is classified based on its port and switching position. For example, 2 by 2 valve means 2 mention the number of ports and next to mention the switching position. 3 by 2 means 3 ports and 2 positions here or 2 way it works. So first one is we can see here. Here we are having 2 ports and 2 position. It may be once it will be a default position. It is a blocked position. Then whenever it's switched on, it is taking this position. So flow will be there. So just like a switch you can use or a limit switch you can use this 2 by 2 volts or 3 by 2 volts. Okay. Then some of them are normally open, some of them are normally closed. Normally open we are using, normally closed also. So it depends upon the default position. It may be normally open or normally closed. Then 4 by 2 walls. we are having. So that means four ports we are having. So port number one, this is a port number one. This port number two, then port number two, then port number three, then port number four. So four ports we are having. How many portions we are having? This is the one portion. This is another portion. So once it works like this, another time it works like this. So similarly, 5 by 2 means so more than one port, that means four ports we are having, five ports we are having, two portions. 5 by 3 means we are having a mid portion. Here we are having different center portions we are having, tandem center we are having, open center we are having, closed centers we are having. So in this 5 by 3, mid portion is closed. So five ports we are having, one, two, then we are having third port, third port we are having, fourth port and fifth port we are having. So five ports we are having, three portions we are having. So one, two, and three portions we are having. So three portions we are having in the 5 by 3. So these are the different types of walls based on its ports and switching portions. We can classify the DCV 2 by 2, 3 by 2, and 4 by 2, and 5 by 2, 5 by 3 we are having. Okay. Then how we are activating these walls? So already we discussed about the different types of DCV. Now how we are activating? There are different types of valve actuations we are having. One is manual actuations. We are having manual actuations. There are manual means you want to operate with your hands or your leg. So it may be pedal operator. Say push button, lever operator, pedal operator. Then return switch also we are having. So this is a return switch. Okay. This is a manual actuation. The next one is mechanical actuations we are having. Mechanically it operated. Maybe cam operator, roller switches we are having. Here it is a roller switch, roller actuated, roller switch in only one direction. Then spring actuators we are having. Both sides spring actuation also we are having. Then stem actuators also we are having. Okay. Then pneumatic actuation. So mechanical manual actuation, mechanical actuation, and pneumatic actuation or hydraulic actuation we are having. It's usually we call as a pilot operated system. So we can have direct pneumatic actuation, indirect also we are having. So indirectly we are receiving pilot signal, which will energetic the. That means we are getting a pilot signal to energetic the electrical signal. That also is possible. So indirect as well as direct we are having. Okay. Then solenoid actuation also there. So a fully electrically operated means solenoid. So single solenoid we are having and double side. So double side also we are having solenoid. When combined, if you are having actuating device with pneumatic with solenoid, we are calling as a combined. So double solenoid valve pilot with manual override also we are having. So these are all the different actuating system. We have different actuating systems we have. Okay. Now we can go for the methods. So already in manual actuations you can see push button, hand lever, foot pedal, and mechanical roller switch we are having. Likewise, hydraulic pilot line we are having, pneumatic pilot line we are having, then solenoid we are having, spring actuation also. To it, what purpose we are having actually to shift the position. So shift the wall position we are having this actuating methods. Okay. So now you see the DCB as pictorial view. We are having 3 by 2 wall. So three ports we are having 1, 2, 3 with the push button we are having. Okay. So it's how we are representing symbolic representation is two cylinder, one of cylinder in we are having a compressor symbol when it is connected and it is moving. So once again we are having so two position 2 by 2, 3 by 2 walls we are having. So three ports, two position. Now it is actuated. Maybe in one of the actuation device, maybe it's a manual actuation or a mechanical actuation or pilot operated. Now we are sending the air pressure to blanket. So this is called blanket. This side we are calling as a blanket. This side we are calling as a rod end. This is rod end. This is blanket. Okay. So we are calling as a blanket. This is a rod end. We are calling as a rod end. Okay. So because of its pressure, Now it extension occurs. Now when we are releasing the push button, immediately it return backs. So now what will happen? So there is no stroke. So what will happen? Immediately. So once the extension occurs, immediately return backs. If it's a single acting cylinder, means it is a it's a spring actuated system we are having. Now we are having a push button. So push button we are having. When you switch on, if you switch on this one, immediately it moves from this position to this position. So that means the pump pressure is connected to the this port. Immediately it supplies to blankets. Okay. So how it will be represented? Symbolic representation is a symbolic representation of the direction. Okay. So one. So always odd numbers are in bottom and even numbers are in the top. So push button 3/2 spring return valve. So now by 2/2 DCV we are having, it's a line diagram. You can see the moments. So when it approaches, so flow is on. When we are pressing, once again it pressed means immediately return back. Or you can have a spring return, so immediately return back. So 3/2 on. So once we are in actuated, immediately it takes supply to the cylinder. When we release the push button, immediately it return back and return back the fluid. So once it was diverted, drain to the open, and another time it was giving supply to the cylinder. Then 4/2, there are four ports we are having. So one, two, three, four ports. So what will happen? So when we are having the motion, immediately this energy supplied to the cylinder. In the opposite side, the pressurized air has to be released. That will be released towards this direction. Towards this direction. So it is coming inside and it will be released. Okay. So now once again it was pressed. What will happen in opposite direction? It works. We are giving supply to the blanket and retraction. Sorry, extension occurs. Then 5/3 lever operated spring centered control valve we are seeing here. It's a 5/3 DCV with spring centered lever operated switch. Okay. So it's a symbolic representation. So centered three portions we are having. Center portion is a closed center. Then we are having five ports. Three portions we are having. It will be operated with a lever operated spring centered. So we are having a spring centered system. Okay. Then another one special valve we are having, this name is called check valve. It's a unidirectional valve, permit the free flow in one direction only. It is a unidirectional valve, permit the free flow in one direction only. So everywhere you can see in our home also, we want to have continuous flow in one side, we can have this check valve. Even when you are going for speed control circuits or any flow control circuits, you can have, or you want to increase the speed or decrease the speed, you can have a check valve. It helps to support. Or in a pilot operated check valves also having, that is based on that opposite side also it will work. So it is called unidirectional valves. It permits the free flow in one direction. You can see here if you are sending flow in this direction, it will be allowed. It will compress it and it will move. When you are coming this side, the ball won't allow. It's a ball type. It won't allow the so fluid block in this direction and fluid allowed in this direction. So only this direction the fluid is allowed. So we can send fluid like this only. Here also we can send fluid like this only. But here it is blocked. Here it is blocked. So this direction it is blocked. So this direction it is blocked. Okay. So it's a symbolic representation. You can see it's you have to draw symbol like this. So it mentioned the check. So you can see now the simulation, how the flow will be there. So when you start, it is moving, it's allow the fluid. But in a return flow, it won't allow. The ball blocks the. Okay. Then another one wall, we have seen the flow control wall. So we have seen direction control wall in a pneumatic system. Different types of direction control wall: 3 by 2, 2 by 2, then 4 by 2, 4 by 3, 5 by 2, 5 by 3. We are seeing. Now we are going for flow control wall. So here one example, a flow control wall. It's a needle wall. We can see the pictorial view of the wall also. Now we can see how the flow will be arrest. So it will be arrest. The flow will be there. Based on your need, you can adjust the knob and you can stop the flow or increase the flow or decrease the flow, whatever you want. It's a symbolic representation. Okay. Where is the, it's possible to vary the, that is a speciality in the flow control valve. So especially these needle valves we used in air cushioning system. So we have a cushioning cylinder with cushioning, there we can have a needle valve to arrest the flow or slow down the flow to avoid the piston hit on the wall of the cylinder. Okay. Now we see the different types of cylinders, single acting, double acting cylinders are there. So you can see different types of cylinder. So this is single acting cylinder, spring return. Here we are having a double acting cylinder. Double acting cylinder means two ports are there. So double, both sided line. So extension also we need supply, retraction also we need supply. So it is in retracted position. This one is extension, so length of the spoke. So these are different types of hydraulic cylinder, especially linear actuating cylinder. So linear single acting cylinder, linear double acting cylinder with retraction position, retracted position, and linear hydraulic cylinder with extended position. So these are the different types of cylinder. Guys, we can see now the different types of hoses and connectors what we are used in our system. So hydraulic hoses we are using some fittings, levers. These are all specially made. In pneumatic, we use pipes. Here we are using pipe fittings like that. These are all straight couplings, T joints, and we are having different types of joints also. Pneumatic pipes and fittings are the light construction. Pneumatic pipe is made from nylon and generally connects to the piping with push fit connectors. Here, this hoses are hydraulic hoses are reinforced. We use steel reinforced hoses. So rubber hoses with steel reinforced. Because you have to strengthen it and you have to be safe. We work hydraulic systems are more than 20 bar, 100 bar, 200 bar, 300 bar. So, but in pneumatic system, maximum 10 bar or 8 bar we are using. So, we are having normal hoses and normal simple fittings we are having in the pneumatic system. That is a advantage of the pneumatic system what we have in our assembly line operation. Okay. So this is a simple schematic diagram or pictorial view of a pneumatic system. We have a foil unit. So it's a symbolic representation. This is a this you can see a compressor. Then we are having a foil unit. So a foil unit. Then we are having a, so this represents a foil. This is a pressure gauge, lubrication and filter. Then we are having 3 by 2 wall, 3 by 2 DCV. So this is a foil unit. This one is compressor. We are having a compressor. Then we are having a 3 by 2 wall. It's a symbolic representation 3 by 2 wall. 3 by 2 DCV. Then we are having a direction control wall. So this 3 by 2 DCV is used to switch on off. So 3 by 2 spring return wall. Then another one pilot operated spring return wall 4 by 3 we are having. Sorry, 5 by 3, 5 by 2, 5 by 2 we are having 1, 2, 3, 4, 5, 5 ports and 2 portion we are having. It acts as a direction control wall to direct the flow to the cylinder. So it's a blank end, so one is the rod end. So based on the extension retraction will be there. So it's a pictorial representation of the components. So we have a FRL unit, compressor, FRL unit, one switch we use to switch on the system, then we are having direction control valve, then we have an actuator. So these are all the basic components of pneumatic system. I think in case you understand thoroughly about the basic components, simple components in pneumatic systems. It starts from compressor, so there is a filter also. Then we have a FRL unit. Then we have a 3 by 2 valve to switch on the system. Then we have 5 by 2 direction control valve to divert the fluid to blank end or which direction we have to proceed. For that we are using a proceed the actuator. For that we are using a 5 by 2 DCV. So these are all the uh, pneumatic components in our system. Okay, basic pneumatic. So now, so thorough in these components. So now we can go for the representation. How we are representing the represent the walls or the uh, cylinders, whatever the components available in the system. The symbol we have represent the symbol used to represent an individual element display the following characteristics. So we are going to represent some symbols which has to represent the function, actuation methods, number of connections, number of switching positions. So it tells about the function, it tells about the actuation method, it tells about the connection, number of connections, it tells about the number of switching position, it tells about the principle how it operates. Then the flow path also it represents. So graphical representation which is used to represent the individual element characteristics, especially about its function, actuation method, number of connections, number of switching position, then principles, and the flow path. Okay, so we can see one example. We are having a direction control valve 5 by 2 pilot operated spring return direction control valve we are having. So we can divide it into three. One is left actuating device, another one is wall action, then another one is right actuation. Here, left actuation is a spring. We use a spring to actuate this left side. Then action are two ways. So maybe left side or right side it has to actuate. Then right side we are having a right actuator, which is a pilot operator. It mentioned is pilot operator. We are having different types of direction control. As an example here, the symbolic representations we are having. Here it is 3 by 2 walls we are having. 3 by 2 walls we are having. Then if it is having a pilot operator with solenoid combination, we are having it's spring return. Then here it is pilot operator with the 3 by 2 walls we are having. So this is pilot operator, spring return. Here both side pilot operator. Here also both side, but 5 by 2. This is 5 by 2. 5 by 2. Here it is 3 by 2. Here it is 4 by 2. Okay. So these are some example. Now we understand how it was represented. So don't think it is represented. It is used to represent the characteristics of a particular command. Okay. Don't think it represents some other things. It don't tell about the size. It don't tell about the size or dimension. It don't tell about the manufacturer or method of construction or its cost. Operation of the port also it won't explain. The symbols won't explain all these things. And then it won't tell us about the physical details of the element or union or connections other than junctions also it won't. So don't think this graphical representation tells about all the uh, characteristics like geometrical characteristics as well as the manufacturer attributes. It won't tell about geometric and manufacturer attributes. It only tells about the function of the particular component. Okay. Now, how we are representing this ports? So we have hydraulic system and pneumatic system. According to ISO 1219, in hydraulic system, it was represented in alphabets. It was represented in alphabet. Pressure ports we are having, it is connected to the pump, and working ports A and B we are having. Then SS ports, reservoir R, as well as S also we are having. Then pilot lines we are having, left side Z and right side Y. It is according to ISO 1219. ISO 5599, the ports are designated in numericals. Numericals it was represented. So all the odd numbers 1, 5, 3, it represents the bottom, and it 4 and 2 is connected to the actuator. Okay, or the cylinder. It is connected to the actuator or the cylinder. Now I think you understand how it will be marked. Okay, so you can see here the numbers are actuators. So here is a pneumatic system. So it was numbered 1 and 3. So odd numbers are in bottom. You can see here odd numbers are in bottom. Odd numbers you can see here in bottom, and even numbers are in the top. So please understand, numericals we are using for pneumatic system, and alphabets we are using for hydraulic system. Now guys, to understand the basic components of pneumatic system, this is half an hour video. In the earlier video, if you want to know about the hydraulic components, means you can go through the previous video. You will understand more about the basic components of hydraulics and pneumatics. If you are all thorough in these basic components of hydraulics and pneumatics, now we can, next video onwards, we will see the applications, how it will be worked. And also we will discuss about the simulations of the fluid sim, first of fluid sim software we also are going to discuss. By using that first of fluid sim software, we are going to simulate the applications for exercises what we have in our classes. Okay. Thank you so much. Thank you for your patient listening. Thank you.